Now I'd like to invite Day 2 keynote speaker, Mr. Eric Byres, CEO, ADOLUS Inc., for his presentation on the evolving threat to the industrial control system supply chain. Welcome, Mr. Byres.
So thank you very much. It's a real pleasure to be here today. I came to the very first kayaks event back in 2014 and have been here a couple of times since. And this is just one of my favorite events of the year because of the diversity of the speakers that you have, the enthusiasm of the audience. It's just an outstanding event to attend. So it's great to be back. And I want to talk today a little bit about how the whole industry is evolving. The threats to us have been evolving. The attackers have been evolving. What's been going on? How is the landscape changing? And before I do that, I realize I need a little clicker thing. So I'll be back in a moment. Don't leave. Thank you. Great. All right. So I'm going to talk about in sort of 3 steps here. First of all, I want to talk about the actors, how the actors have been changing over the last decade. Then I want to talk about how their attack methods have been changing. The attacks that we saw 10 or 15 years ago are no longer the attacks we see today, or no longer the attacks we need to worry about. The old attacks still kick around, but. And then I want to talk about how we're going to address this, how we're going to fight back. And there's a little hint. It's about how are we going to build a community. Okay, so who's behind cyber hacking today? Is it a kid like this? No, that's 1970s, 1980s. It's not him. It's really evolved into a series of actors. And if you're in Canada, this is the Canadian government's version. Behind me, every country, and I'm sure Kuwait and all the countries in the regions have their own model for who it is that wants to attack their national facilities, whether it's critical infrastructure facilities or financial facilities. But every country builds one of these maps, and they really make sense. You know, we've got nation states and hacktivists and enthusiasts. We've got the criminal organizations who are doing it for money. We've got the terrorists, and we've got the insider threat. And the models, depending on the country, will look slightly different, but they basically follow this model. But there's another model that I sort of use in my own mind, which I really, really like, and that was put together by Dr. Andy Osment, who's now the Chief Security Officer at Goldman Sachs. And the way he says it is that the world is divided up into vandals, burglars, thugs, spies, and saboteurs. And for Andy and for me, and I think for you, it's those last 2 we really got to worry about. Now, I like his model a lot because it not only tells you who they are, but a little bit about their motivation. Let me give you some examples. So, vandals. Anonymous is a really great example of vandal. They're usually threatening to deface your website when they get to, usually driven politically. This is an example of a website in Spain as a result of actions against the Catalonians. And so usually has this sociological, political, ideological flavor to it. But it's usually pretty amateur. Rarely is it highly professionalized. It certainly isn't trying to stay under the radar. Move on, and you've got the bad guys, the burglars. These are organized crime, and phishing's a great example of that. What's the purpose? It's money. It's usually small groups, usually multiple groups that are coordinated together to build an entire service chain. And it can be phishing, it can be ransomware, like this picture here. It can be large-scale theft of credentials for harvesting later, for bank harvesting, but driven by money, usually relatively competent, but not large organizations. So what about the thugs? Has anybody seen this movie? Hey, oh, great, great. Okay, so if you haven't seen the movie, it looks like most of you haven't seen this movie, you didn't miss much. It's not a great movie. It's called The Interview, and it was about these 2 guys who go over to pretending to be TV personalities who were going to interview the president of North Korea, Kim Il-jung, and assassinate him. Well, I didn't think it was that funny, but that guy really didn't think it was funny. He was really upset. And he basically got his national intelligence agency to run attacks against Sony to try and stop them from launching this movie. So they had a whole series of embarrassing exposures where he released things like their scripts in advance, their release dates, their customer lists and customer intelligence, private information by senior executives. And so what was he trying to do? Was he trying to get money out of them? No. He was trying to coerce them. He was trying to act just like a thug, and he was successful. This movie never was released in theaters in the United States. I don't know about it out here. So this is, thuggish behavior to try and get somebody to intimidate somebody, and it worked well. Or not somebody, a whole company, a large company. Then there's the spies, and the very famous spies are, of course, the People's Liberation Army Unit 61398, and they run a series of campaigns, probably out of that building, although they've never invited me for a tour, and that's probably good. And what's interesting about this is it's very subtle, very professionalized. It's a full-blown military operation. Yesterday, I can't remember who mentioned, I think it was the FireEye presentation, talked about how when you're looking at an APT, they're actually running at a 9 to 5 or 6 to 3 schedule. You can tell that it's a professional organization because the activity, they clock in and clock out. And you can see that in those attacks, and you can certainly see that in the attacks coming out of these Chinese attacks. Very, very organized, coordinated, professionalized attacks. In the case of China, we're looking at attacks that have been focusing on companies that are part of their 5-year plan for strategic industries. We're not talking about trying to destroy anything, but they have been going after organizations in the region. And it's really around intellectual property theft. And then lastly, the last group is the saboteurs. And saboteurs, just like physical saboteurs, are typically a military political operation that is trying to cause destruction for military political purposes. And a great example is NotPetya. Okay, so if you read this, kind of looks like a ransomware attack, doesn't it? Send bitcoins to this address. What would happen if you sent bitcoins to this address? Anybody know? Nothing. If you look at the code with NotPetya, there is no decryption keys. Those are destroyed as the malware takes over the machine. And so NotPetya is a really good example of obfuscation of an attack that was made to look like it's a criminal attack when it's actually a political attack. And I'm sure you're probably all aware that the result was an attack inside Ukraine. In fact, if you're not, and it actually was launched by taking over the software called MEDoc, which is accounting software used to file taxes in Ukraine. Now, this is a really interesting attack vector because what they're doing is they're not going after the intended victim. They're going after a supplier to the intended victim. MEDoc is a tool that the victims would use. So attack MEDoc and you'll get to your victim. And in the case of this, it was very, very random, very wide scale and indiscriminate, a lot of collateral damage. But probably the intent is, hey, if you're a company that has to deal with Ukraine and has to file taxes in Ukraine, then you're an enemy of us and we're going to attack you. So very broad brush, wide scale, high risk attacks. We've seen this sort of attack when, this is sort of like a, well, I'll talk about that in a second, actually. Okay. So if we break it down, we got the Vandals who are not that skilled, and they're really just trying to make a point. We've got the burglars who are much more skilled, but smaller organizational units, usually chained together, looking for $1. We've got the thugs, sometimes very professionalized from nation states like North Korea, but generally not that well organized, and they're trying to coerce people. And then people we got to worry about in the industrial field, in ICS, are these guys who want your intellectual property secrets and these guys who want to destroy your facilities. Now, in region, we've had a number of these incidents where clearly these actors have been playing. I mean, what's happened to the attacks in Saudi are pretty good examples. The Trident attacks, that's a cyber attack with clearly intent for destruction. And that sort of parallels, you know, the same sort of attacks that we see with drones into Saudi. What we're seeing here is political, military-driven operations, very different than a decade ago or 2 decades ago. So who's doing this? I say it's nation states, and it really is. They may have actors acting on their behalf, you know, sort of irregulars, but they're definitely nation state funded. Okay. And what do nation states want? Why are they trying to do this? Well, it's going to be clearly espionage as a big purpose. But more than just straight espionage, we're going to see focused intellectual property theft if it benefits the nation state. Okay. Why? Because it will give them an economic advantage. What else would somebody use these attacks for? Propaganda purposes. Okay. So we'll see these types of attacks. Interference and disinformation. We've seen this particularly in electoral attacks on electoral systems. And then disruption and destruction. And clearly an attack like Trident is intended for destruction. One doesn't play with a safety system just for fun. Okay. So who's been doing it? I'm just going to walk through the main players. We saw yesterday, Omar talked about, I think it was in Omar's talk, he talked about the attackers that they were seeing into the honeypots coming here in this country, or in this region, the regional honeypots. I thought that was really interesting. I actually have a little side comment on that, is why so much activity here? You know, and he commented that there was so much activity in the Middle East, and maybe it was due to lax regulations. No, I think it's target attractiveness. You, unfortunately, live in a region with a fair amount of instability, with a fair number of shooting wars going on around you, with countries that would be quite happy to bomb you or bomb you or cause actual civilian damage if they could. So what we're really seeing here is a proxy for military and political aggression or attacks. Anyway, back to this. So the United States, clearly the U.S. has had some activity in this region with attacks like Stuxnet and Duku. Very, very highly skilled. These are professionalized attacks, and the whole idea is to stay under the radar. They're not trying to blow anything up. They're, even an attack like Stuxnet is not blowing things up. It is trying to look like mechanical failure. It's trying to stay under the radar and be assumed to be there is no attack, that this is completely just normal wear and tear on centrifuges. Okay. Israel, very, very similar sort of mode. Something that I thought was interesting in that list of who was attacking the honeypots here. Israel was not on that list. That's interesting. I'm really a little surprised at that. I suspect it is probably because they're very good at not being found. And again, very low impact, a really, truly a good example of what we call advanced persistent threat. Who else? China. Another very professionalized organization. I talked to you about their advanced persistent threat teams. Multiple, very professional, whole building of people doing this work. And again, subtle, skilled. They're not going to be blowing up your facilities. They're going to want to sit and monitor. And exactly that's what we've seen in North America with the attacks. They are not destructive attacks. They are attacks of patience and data collection. Okay, who's next? North Korea. Whoops, jumped one. North Korea. Very different mode of operations in North Korea. They tend to focus on their stated enemies, which is South Korea and the United States and Japan. Those sort of attacks are destructive. But they actually have two different units doing the attacks, or at least it appears to have two different units. One that we generally in the trade we called APT-38. is actually got a really unusual, very different for a nation state. It's financially driven to get foreign exchange into the country to be able to fund the rest of their operations. So these APT 38 really tends to go after banks and financial institutes to try and get large lumps of cash so they can run the country. And then Lazarus tends to do the political and military type operations like we saw against Sony. Very, tends to be a bit crude and unprofessionalized and particularly noisy. And then there's Russia. Russia tends to focus on political, military espionage, particularly against NATO countries, and we see this, for example, in Ukraine. Their professional teams, likely, and I mean, I don't know personally, but I'm going to be taking a guess, it's FBS or the GRU that is sponsored. Possibly some of the teams look like they're semi-professional with a lot of government support. The relationships with criminal organizations in Russia is really unclear, whether some of it's getting outsourced to criminal organizations, but there's the tie-in is kind of unusual compared to other countries. You'll see massive disinformation campaigns, for example, what we saw in the US and British elections, or massive and indiscriminate denial of service or destructive attacks, and NotPetya is a great example. Really not concerned about collateral damage. Just get the malware out there, don't try and be subtle, just destroy everything you possibly can. So a very different type of attack. Then last country that I think is really a player on this space is Iran. Probably their teams are really associated with the Revolutionary Guard. They're running typically sabotage campaigns. I mean, they saw Stuxnet as a sabotage campaign quite reasonably. They saw that as a military sabotage campaign against them, and they've really tried to do the same thing. But what's interesting and what's changing, and there's a really good talk this Thursday by a researcher from Microsoft, what we're seeing is their targets are changing. And there's been a change in the last 6 months of the type of attack target. Previously, Iran would be doing lots of sort of pretty crude password cracking attacks against a wide range of intended targets in the US. What we've seen is a shift away of the actual intended victim to the suppliers of the victims, and the suppliers are ICS suppliers. So this delivers a message to me that they are now pivoting away from pure attacks, particularly against, say, financial institutions, to the suppliers. And this is starting to really concern me because we saw this in NotPetya, we saw this in Stuxnet, we've seen this in one of the ones I'll talk about in a second, Dragonfly, this interest in, hey, if my victim that I want to get to, the oil company that I want to impact, is too hard, why don't I go after its suppliers? Why do that? Why go after the suppliers? Well, yesterday Ben talked about the attack chain and how it's a series of steps an attacker must do. And if you can block any one of those, you've ruined their attack. And so the more steps, the higher probability you're going to be able to stop them. And in control systems, we end up with this looping attack chain, because you've got to penetrate the organization, and then you've got to penetrate into the control system, and if it's a Purdue model or a zone model, you've got to keep on going through that little loop of where you do internal reconnaissance, you look for lateral movement or penetration into a new area, then you do your data analysis, then you have to go and get a foothold in the new area. So an attack chain against an industrial control system is actually pretty long for the most part. Can be quite difficult to carry out, and there's a lot of opportunities. The good news, a lot of opportunities for you to intercept them. So along comes, how do they short the kill chain attack? How do they make them so that it's possible they can get in quickly? And probably the best example of this is an attack called Dragonfly. Dragonfly was going on right about the time we had the very first kayak conference, in fact, 2014. And in this case, the attackers are not going after their victims. They're going after 3 ICS companies in Europe. And what do? They penetrate the websites of these 3 companies, and they replace the legitimate download software on those 3 sites with Trojanized versions that contain malware called Havocs. So we've now taught our technicians, hey, patch early, patch often. It's important to patch. And so the technicians and the engineers on the plant sites would go up to the vendor's website and say, hey, new software, cool, I better download it and use it. They would download that software and walk it into the plant. Now, this is a brilliant attack strategy for 2 reasons. First of all, I was lucky enough to actually spend quite a bit of time on one of the victim suppliers for about a year later and learn a lot about what happened there. And this is incredibly effective because the software the technician is saying, I've got to update that equipment. And they would walk it right past the firewalls. If there was whitelisting on, they'd turn off the whitelisting. If AV went off, oh, no, that's just a mistake with AV. I got this from the vendor's website. It must be good. And of course, when they installed it, then it called home. Now, the return on investment by the attacker is amazing in this case. It's just really, really scarily good. On the one company that I worked on, the malware was sitting up, or the infected packages were sitting up for about 2 weeks in 2014, around January 2014, on their website for download. 300 different downloads were run at that time, 280, 300. Okay, so you've infected one site, now you've got 300 people downloading. But think about our industry and how it works. A technician or a manager will download a package. Will he do that for everything he has to upgrade? No, he's going to download it once, and then he's going to go through his entire facility and do all his upgrades. So we've got a multiplier effect. Maybe, in a typical large industrial plant, might have had, some of this equipment might have had 20 or 30 or 100 of these units. You're seeing one attack on an industrial supplier gets you 300 infected sites, each one of them infecting maybe 20, 30, 40 different devices on the plant, all calling home. So the return on investment for the bad guys through supply chain attacks are phenomenal. Okay, we're almost out of time here, so I want to keep moving. So when I started researching this, I was particularly concerned because I sold firewalls, and firewalls wouldn't help me at all. And I thought, well, maybe code signing will fix it. But if you look back at Stuxnet, you see that code signing actually was part of the problem. Stuxnet stole the signing keys from 2 Taiwanese, or the designers of Stuxnet stole those keys from 2 Taiwanese equipment manufacturers and then used that as a get-out-of-jail-free pass to spread itself. But it's worse than that. As I've started to play with code signing, what I'm seeing over and over, and there's some really good papers if people want to approach me on them, is that a lot of antivirus packages, a lot of so-called systems that are checking, just see the fact that there's a certificate attached to the back end of a file and think that's good enough. They're not actually checking the hashes in the certificate. That's a little bit like walking into the airport with your passport and the security guard saying, do you have a passport? Yes. Thanks, bye, go. You have to follow the full process. And we're not seeing that in code signing many, many times. The mere fact that something is code signed doesn't mean that the code signing is valid. And so we really need to address this and figure out, if we are going to depend on code signing, how we're going to drive the actual process out of being just a technology and into an actually useful functioning problem or solution. Now, I believe this is solvable. I believe that the reality is that there is a lot of information out there. But the typical technician in a refinery is dealing with thousands, if not tens of thousands of devices. He's dealing with hundreds of different suppliers. And there's hundreds of tools he could run every package before he uploaded it to make sure it wasn't evil or something that was coming from an attacker. And then there's hundreds of databases. I mean, just think about just any, say, PLC upload. Well, you can go to the vendor site, you can go to the vulnerability databases site, you can go to all sorts of really cool reports out there. So there's too much information. And what I realized as I started to work on this is that we really needed a way to cooperate. That if you gave me a package and said, is this package safe to load into my controllers or into my safety systems? And I'd say, give me a day or two and I'll tell you. but nobody's going to take the day or two. We really need to aggregate this. So 3 years ago, I was funded, along with Dr. Butts and Billy Rios, to put together a program and a solution to try and figure out how we can validate and verify the quality of software and firmware we're loading into the systems in the field. Out of that came a program called FACT, Framework for Analysis and Coordinated Trust. And yesterday we heard some really, really good examples of how we needed cooperation. And this is what I see as needed here. Probably the industry that gets the most effective defenses against these sort of attacks is the banking industry in the United States. Why? Because they have a really good cooperative network between the banks. On the other hand, in the oil and gas industry and the petrochemicals industry, we tend to be very, very regionalized. We don't tend to communicate as well as anywhere near as well as we should. So the idea behind FACT is to be able to provide a communications platform for everybody in the industry, the vendors, the asset owners, the integrators, so that they can understand what they're seeing. What it does is generally produces a trust score, like a credit score, for every piece of software currently being used. So the idea is it's a community effort. We want to get the asset owners involved, we want the vendors involved, we want the integrators and consultants involved, and we want absolutely all the people involved in security, like Ben's company, Dragos, or Nozomi, or any of these types of companies that are trying to do threat modeling and threat analysis. Understanding the software that their customers are starting to load is absolutely critical. I'll give you a quick rundown of how we envision it, or how it is working. It's, who knows the most about a blob of software? Well, hopefully the vendor does. So the idea is the vendors can submit fingerprints, not their actual software, but fingerprints and markers about their software into a cloud database. And we've developed a whole bunch of low-impact technologies through this DHS grant to allow vendors to do very, very, very fast processing of what they're about to release, and release it up into the cloud in a way that absolutely leaves their intellectual property intact. Using cloud and systems in the cloud and AI systems, we break that down. We basically do some AI and analysis on it. And then from that, we can go out and say, hey, are there any subcomponents in there that we're seeing showing up in, say, virus databases or the National Vulnerability Database? What are the components in that blob of software you've got? In other words, what else is being supplied in? And out of that comes a score. And then from there, asset owners, like yourselves here in the room, can then say, hey, I'm about to load this software, or I've downloaded this software and I'm going to distribute it to this facility, or this is going to be our corporate standard. You can get a score that gives you an idea of how much it's trusted by the community. So to wrap up here, and I think I got 2 minutes, what's important to note here is that we're seeing a sea change in the way the attacks are going and the attackers are going. We're now in the oil and gas industry and the petrochemical industry no longer dealing with kids. We're dealing with state-sponsored attackers with very large budgets and lots of resources, and most important, lots of time and patience. We're also seeing that these highly skilled adversaries are willing to take extreme risks to be able to take these make these attacks work, but also a lot of time. Okay. The reasons for these attacks are changing from just, hey, I'm a cool teenager and I want to show off, to political and military motivations. So very, very different. And what's also interesting is that the interest of these nation-state attackers, ICS control systems, have now firmly become part of the target, part of their interest. It's in the radar. You're no longer out of the radar. You're right in the middle of the bullseye. Okay. And probably the most important thing is, how are we going to deal with this? And I really believe the only successful model is start to get defensive cooperation, information sharing between all the players in the industrial control systems. Not just between national oil companies, but the vendors need to be involved, the companies doing risk and security analysis need to be involved. We need to have a platform for information sharing. And later this afternoon, you're going to hear a great talk by John Matherly, who will talk about his platform. And it's another great example about how, if you get information sharing, then somebody like Joel Langle can come up and say, hey, using John Matherly's platform, I was able to help protect this particular facility. And not only that, by using this information sharing, I was able to determine that there were other airports in the US that were under attack. So you can see that if we can build mechanisms for accurately sharing information between all the players, and the important thing is all the players who are interested in defense, we really have an opportunity to improve the defenses and actually secure our control systems. Thank you very much.